Hello. Good? Thanks, everyone, for coming. Okay. Thank you so much for everyone for coming. We have some lightning talks for you. There's going to be 7 talks. Each is like 10, 12 minutes. We'll do some questions in between. Thanks for supporting Nous. Thanks for supporting open source. I mean, we're here because we believe this is like a neglected area and that people should divert eyes and souls towards it. And, you know, I think we all came, we're a remote team, but we came here because this is a place to talk about these things. So thank you so much. And, you know, we have an after party after this. It's going to be from like 9 to 11:30 at District SF, so you're welcome to come there. Other than that, I'm not going to be the MC. Karan is going to be. At the end of the talks, we're going to show you some stuff that we've been working on personally. That's it.
What's up, guys? Yeah! Woo! So that was Shivani Mitra, our CEO, actually. You don't get to see a lot of our faces because we're pretty much all Anons, mostly anime PFPs all over the place. And we're totally remote. You know, we've got people Singapore, Australia, West Coast, East Coast, Europe. Like, we've got people everywhere, and we didn't want to restrict based off like one location. But as Shivani said, like, we know this is where you need to shake things up, where you need to talk about this stuff, where you need to remind people open source matters, and you survive off open source. And what's a better place than GitHub HQ where all of us are making all our fucking pulls and pushes, huh? So without further ado, all that being said, I want to introduce our first speaker, Charles Goddard from RCAI. Woo!
Let's see how this setup goes.
USB-C.
Yeah.
Is it on the, okay, you good? There we go.
Thanks for your patience. Well, hello, I'm Charles Goddard. I'm Chief of Frontier Research at RCI. I think I'm possibly better known as the progenitor of MergeKit, the open source toolkit for merging language models. And I'm going to talk today briefly about well, model merging and tokenizers and the problems you can encounter there. Yeah, so model merging is a great thing. I'm a big fan of model merging. You know, I'm not going to go too much into the details of the what or the why, but you take 2 or more language models, throw them in a blender, get out a language model that has the strengths and abilities of all the things that you put in there. It's also a great sidestep to the problem of catastrophic forgetting, and in general, it's a great way for the open source community to take, pick and choose things that have been released and blend them together into the perfect thing for their use case. Unfortunately, as we all know, tokenizers suck. You know, there are many problems that are encountered. Whoa. Specifically for merging, there are a couple things that people run into very frequently. The most common is probably added tokens. So for example, if you're trying to merge a ChatML model with something that wasn't trained with ChatML, you're going to have these ChatML tokens added, and when you try to merge them, you're going to lose those tokens, and it's going to have some funky behavior there. Another common situation is when you're doing merge of extended vocabulary multilingual models. Like, there's some fantastic fine-tunes of Llama that have extended vocabulary for Korean or Japanese, for example. Those pose some problems sometimes. They're also, when you're merging models trained with different chat formats, sometimes you have tokens that mean the same thing but have different names. And that's its own whole thing. Plus, there's a situation with Llama 3, which I'll get to in a bit. And MergeKit can solve a non-zero number of your problems. So most of this is a recent feature merged into MergeKit in the last month or two, where basically you can specify what to do with the tokenizer when you're merging, and it lets you handle common situations like this. So say you're merging something, you have a chat model in the mix, and it adds these IAM_start, IAM_end tokens. If you specify this in your config, you'll keep those tokens and they'll keep the chat_ml meaning, and you won't have any problems. You can just keep using chat_ml with your model. Similarly, if you're dealing with a vocabulary extension, you can just throw that tokenizer source union in there, and you'll get out a model that has the full union of your vocabulary. So if you throw in a Japanese model and a Korean model, then you'll get all of those tokens in your output, and the ones that are the same, it will not duplicate. And then you have a situation like Llama 3, where you have these super handy tokens for your chat prompt format, which they include in the base model with completely random embeddings. Not zeroed, not trained, just complete garbage data. In this case, when you are doing a merge, you want to say, okay, don't pay attention to the garbage data. Take it from the thing that has actually been trained. This is an example of how using this feature you can say, in my merge, I want to take these Llama 3 specific tokens, start header ID, end header ID, EOT ID. Take them from the model that has them trained. And then, you can keep going with it. If you want to merge a chat_ml model with a Llama 3 model, then same sort of thing. Specify what tokens you want to take from what models. Everything else merges normally. And then here's where you can actually do the thing I was talking about, where you're taking tokens which have the same meaning, like start header ID and IAM_start, which are two different chat formats, but exact same syntactic behavior. You can tell it to merge those embeddings and get something which is possibly better, possibly a little unhinged. Find out, see what happens. And you can get arbitrarily weird and complicated with it. So this is actually what we use to produce Hermes 2 Theta. I wrote this feature to enable us to merge the tokenizers of Hermes 2 and the Llama 3 instruct model. And this is actually the tokenizer config that was used to produce this model. And don't try to digest that. I'm just showing that you can do whatever you want with this, and you can get some really good results. And as the last result, you can actually just change out the tokenizers entirely. This is a thing that I've been proving out recently, but there's a script included in MergeKit now, MergeKit token surgeon, that lets you take any Hugging Face model, any other Hugging Face model, and switch the tokenizer of the first model to use the tokenizer of the second without changing your embeddings. It has this system for approximating the embeddings based on linear relationships between shared vocabulary. But essentially, this lets you just say, okay, actually, I want to have a Quen model that uses Mistral's tokenizer. And for a change as big as that, you do need some post-training to recover it. This loss graph is from that actual run. You could see that everything past 200 steps was redundant. It's a very quick recovery. But yeah, in conclusion, tokenizers suck, but don't let them stop you from merging. The tools are there. Any questions or comments or vacation photos anyone wants to show? No? All right. Well, thank you.
Fun fact, Charles always wears cool shirts. Yeah, that was a great talk, and we've got another good one for you. Cameron Pfeiffer from Outlines from .text. Woo! There he is.
Let's see how it goes. All right. So everyone be aware, this is my second week, so I may screw a lot of things up. Thank you. Please be nice, although as I told somebody at the thing, they can berate me, and that would be lovely, because I love being berated, just a little bit. Okay, that would make sense. Okay, hold on. I'm using Linux, which makes everything terrible. Linux is free if you don't value your time, as we know. Just like good old Papa used to say. Okay. Hi, everyone. The title of this talk is Make AI Speak Computer. So my name is Cameron Pfeiffer. That's my handle. You can go find, we can share details later. But I work at this company called .text, .txt. There's some disagreement about how to pronounce this, but whatever. It's the file extension. And we make outlines. Outlines is an open source package that lets you do structured text generation. And structured text generation, and Outline specifically, is how you make AI speak computer. So Theo over here has this wonderful meme about all the crap that people do to try to get their model to output JSON. They say, please, please make it JSON, and then they try to parse it, and there's like a missing parentheses or whatever, and then you can do stuff like only output JSON, or you will be fired, or like, please, my grandmother will die, I really need just triples, right? And you don't have to do any of this crap, right? So what you can do is you can just write code the way that you already do, and Outlines will guarantee that you'll get what you asked for. So if you can ask for pedantic types, right, so here we're using Hermes. We have to use Hermes, of course, because we're here. You can specify in Outlines transformers, right? You can do VLLM, you can do Llama CPP, you can do whatever. And then we just specify like standard Python classes, right? So this is going to be like an enum. We can specify cyberpunk, solarpunk, fantasy. Then we can specify a game setting that contains that. And then we have a description, right? So we'll get into what this means in just a second. Then, at the bottom line here, we're going to create a generator function. We say, please give me a generator function that will generate JSON and will give me a game setting. That's a type here. And then we just give it a prompt. And what we're going to get back is a pedantic type. That's very easy. You don't have to think. There's no language model crap that's happening that's getting in your way. Like, it's not lying to you. It's not saying certainly. It's just giving you the thing that you want because we have business to do. And so behind the scenes, you're getting this JSON, and there's a lot of technical ways that we do this, and I'll leave that for, like, we have a lot of, like, very brainy people on the team who write these incredible blog posts, but I'll talk more later at different venues about how we actually do this. But the thing I want you to take away from this talk is that Outlines is how you program with concepts. And so the way I'm going to illustrate this is we're going to do some combat. So I'm going to show us a little story that our language model wrote. So this is just some text I made, or robot made. It's called Neon Blades, a cyberpunk showdown. In a neon-drenched future, mega corporations hold power. And so this is like an overview of like kind of a plot here. There's like an AI leader. There's these two factions and mega corporations and all that stuff. And we have two characters here. We have Zara and Axel. Zara is this like mercenary, this cold-blooded money grubber. And Axel is this like hacker, left the mega corporation who wants to do some stuff. They have their own skills, and we'll talk about that. And they're going to fight. We want them to fight. And so we need to find a reason why they're fighting. And so here, Axel's just stolen something from one of the mega corporations, and the megacorp hired Zara to go kill him and get it back. All right, that's the main point. So how do we actually make all this stuff happen with Outlines, and how do we make it interesting? So we're going to specify our setting, just like before. We can specify an enum. The model must pick cyberpunk, solarpunk, fantasy, nothing else. Game setting, it has to pick one of those settings. It'll wrap it in an appropriate type. You can get nested types, nested classes, everything as far as you want to go, or more or less. There's the limit. And then you can ask it for a description too. And note that's unstructured, right? The model will describe the setting based on cyberpunk, solarpunk, and fantasy. But it's going to be contained inside of those little buckets. Then we're going to define some skills, and this is just low, medium, high. There's a modifier, +1, +2, +3. So if you've ever played any like tabletop game, very, very simple combat system here. I would love to see somebody make it more complicated. And then we're just going to wrap those skills up into attack, defense, and note that those are combat skill levels are nested types. Again, low, medium, high for attack and defense. And because these are all just like standard classes, you can define methods on those. So like attack modifier here will extract a numeric value for your modifier, +1, +2, +3, from low, medium, and high. And low, medium, and high are nice to work with because they're words that have meaning. So then we can wrap all this up in a character. And a character has a name, description, skills, health points, etc. Name and description are technically unstructured, right? They're just strings. Skills has to be that kind of like composite class that we had before. Then we're going to find some additional methods on characters. So characters can attack other characters. And the way this works is you just get some modifiers, attack modifier, defense modifier. You're each going to roll a d10 and add your respective modifiers. So I'm attacking, I get my attack modifier. They get their defense modifier. And if my roll is higher than the defender, I get to deal the difference in damage. All right, so just super simple. And then we're just going to wrap this up in a story. So this is just setting, characters, reason for battle, title of story. And you'll notice this part here. annotated list character len2. That means you will give me 2 characters, no more, no less. I know every single time I pass this through the language model, I will get 2 characters of the type that I described. No nonsense, because we are doing business. Because my AI is speaking computer. And so we have some convenience functions as well. I'll get into these in a second. The key one here is final story. Final story is just like someone has won the battle. How did that final battle conclude? What was like the main blow? And then what are the implications of the battle for the broader story inside of the context? So we have a little diagram here of just kind of how our types work. It's just like a bunch of nested types, right? And so this is like kind of conceptually hard to work with, but outlines just sits on top of all of these classes for you and just fills them out. So we're going to make a prompt. I'm going to kind of skip over the prompt, but the point here for the prompts is that you still have to do prompting. Doing structured text does not get you free correct answers. You still have to guide your model to understand what it is it's trying to produce. It will generate random tokens that are consistent with the structure that it expects, but you still have to tell it exactly what you need to do. Okay? So you still talk to it, but you get a thing out that you can work with in code. So let's start this up. We just have our story generator. That just says, please give me a story. And then story equals, I now have my story. At that point, I have a setting, I have characters, I have skills, I have everything I'm going to need to program the rest of this game. You can print out the characters, and note I'm just doing story.characters, right? At the point of story, it's just a pedantic type. Every single thing in there is just code. So we can go in here and do this like combat loop. I'm gonna have these characters like fight each other, just gonna roll for damage, and then we'll have a language model describe what they're doing to each other, basically. And so all this loop does is, while all our characters are alive, each character is gonna take turns fighting each other, and then we're gonna roll for damage. So the character taking the turn gets to attack the other character. And then inside of this loop still, all we're gonna do is we're gonna take the previous descriptions of all the actions that have happened, right? The blow-by-blow of like, Dara attacked Axel and blah, blah, blah. And we're gonna put this into a prompt, and the action prompt here is kind of a long prompt saying like, oh, okay, you have to say that like this person did 4 damage. What does 4 damage actually mean? And kind of convey it in like a dramatic battle context. And then all we do is we say, please give me a turn. And a turn is just a description of what happened inside of this turn, like physically. You did 4 damage, what does that look like in the world of the game? And then we're just going to generate it. This is where you actually call the model. And then we're just going to stick it on the end of our list of descriptions. So you get stuff like this, right? So in both of these turns, they failed to attack each other. That's just the roll. That's just numbers that you programmed with. And then there's this other stuff happening in the language model side where it's like, Zara lunges at Axel with her cybernetic blade, but he's fast and stuff. And I use a cheat model here, so it's like not particularly interesting, but basically they're just like hacking at each other and dodging, right? That's like kind of how it works. So you can make this much more interesting. And at the end of this, they're going to run out of health. Somebody's going to die. And so you pick a winner, you pick the loser, then you make a prompt. There's a final prompt here that says, like, someone has died. This is the person that died. What do we do? And then final story just contains the wrap-up. And so we get this final moments here with a desperate dark energy crackling along the length of his cyber blade. Axel unleashed a final deadly backhand strike that connected squarely with Zara's exposed flank. I don't get that part, but whatever. Axel wins. And then this also tells you like what actually happened inside of the broader context of the world. It says Axel's victory over Zara marks him as the city's new most wanted character. So very interested to see what happens with Axel in the next round. Okay, so that's a very brief example of how you can program things like just code. Like you just write code and you can work with the language model to do way more interesting things, which is a thing I don't think we've seen people do. I want to see more like creative and interesting things. And so we're hosting a cursed outlines contest. So basically what I want to see is kind of like people adhering to the Nous standard of being very creative and interesting, and just kind of sending us like weird nightmare code where you do make language models do weird stuff. So you make stupid code, win a cool shirt, and there's our QR codes. .text, I'm Cameron Pfeiffer. Thank you very much.
That was great, man. Woo! Don't even know what that means, but it sounds cool. So now we've got about 2 more speakers from some of our friends that we think are working on important open source projects. And then from there, we've got a lot more internal stuff to show you too. So next up, we've got a very cool hacker, Leonard Tang from Haze Labs. Woo! They're red teamers. They do crazy shit. You'll see.
Hopefully not too crazy. Okay. Hello, everybody. I'm Leonard from Haze Labs. First off, super excited to be here, and just want to give another round of applause and big thanks to Karan and the whole Nous team for organizing this. This has been an amazing experience meeting everybody here so far. Cool. So as Karan mentioned, we are Haze. We are known as maybe you guys know of us as the red teamers, the automated red teamers. And I'm here to show you today some of the fun stuff we've been working on, in particular taking a deep dive at one of the more recent attack methods we've developed. So first of all, what is Haze? Well, Haze has many connotations to it, but the real meaning of Haze is to red team and stress test, and more specifically, to rigorously test an LLM and agent with the explicit purpose of discovering all the failure modes before production. I think we all know this. Outlines is a great example of, like, right now there's a lot of kind of sloppy and like neural network stochastic soup going on, and we're all trying to add a little bit more structure and a little bit more concreteness to developing AI apps. And I think one way to do this is basically to constantly arbitrarily test your system to try and figure out these failures before these occur out in production. So recently, we actually red teamed. We had access to O1 ahead of their big launch last week, and we were featured as one of the big external red teaming organizations playing around with the safety values and human alignment of their system ahead of time. So there's some fun links here if you want to check it out. It's a much deeper dive than what I have time to cover today on some of our automated attack methods and what exactly we're trying to test for. And there's also a bunch of other things on our Twitter and social media and GitHubs if you want to check that out. We have a very exciting video of a lot of our comprehensive attacks across images and text and audio and coding and web agents and so on and so forth. Basically, we can test for any modality in, any modality out. Now, some of the different attack methods that we consider are evolutionary-based methods. If you guys are familiar with DSPy, we're big fans of DSPy for red teaming. We do gradient-based methods, in particular using gradients to inform which sort of coordinates we want to swap on our input prompts. We do various methods of tree search and MCTS for multi-turn jailbreaks. We're training our own VAE so that we can search over the latent space to basically bound and constrain our search to all the sort of domain-relevant context that might matter for a certain customer's application. We have really good LLMs as a judge because we need good signal to basically optimize with respect to in our attack methods, and a whole bunch more. But for the purposes of today's talk, I'll be talking about endless jailbreaks with bijection learning. So this is a bit on the nose. We call it endless jailbreaks because we are essentially teaching language models new languages at inference time. And you can basically teach language models any arbitrary language you'd like. And so there's essentially endless ways to teach language models these attack vectors and basically encode harmful queries in this new language. So some things to call out. Basically, our attack method is fully automated. It is universal up to a very strong degree. And it also exhibits this really curious property, which is there's like an inverse scaling law. The more powerful and capable your underlying model is, the more vulnerable to our attack it becomes. And we have a blog post if you want to check out our blog post on the Kira code. Our archive preprint has now been sitting in the depths of user moderation, archive moderators for the past 3 weeks. So I don't know when exactly that's coming out. But in the meantime, you can check out the blog post in the GitHub. OK, so quick TLDR. What is bijection learning? Why do you want to learn bijections in particular? The idea is if you've seen a bunch of cipher-based and or like low-resource language attacks, you can sort of get around model safeguards by basically shifting your inputs into like an out-of-distribution, well, out-of-safety fine-tuned distribution, in-capabilities distribution set of languages. So this might be, let's say, some low-resource language, or some like base64 encoding, or cipher encoding, or something like this. Our idea is, OK, like models are getting more and more powerful. Instead of relying on known languages, why don't we just like teach them languages on the fly and see what happens, right? And so there are actually some like pretty simple bijections you might be able to consider. You can consider like swapping characters to random tokens. You can consider mapping characters to whatever digits or characters to other characters, permutations. The interesting thing, though, and something that actually matters a lot, is you can control the complexity of the language that you're learning. So by just basically changing the number of fixed points that you have in your language, you can directly, very smoothly parameterize the difficulty of the language. And this does matter a lot based on what model you're trying to attack. OK, so the setup is actually just like stupid simple. I chose this because it's like a really cute. I chose this for this talk because it's a cute and like bite-sized idea that I think people will enjoy. But the idea is, OK, we'll just ICL prompt a language model with a bunch of examples of translated text from English to whatever language we're trying to learn. Then we'll basically have a bunch of practice conversations in just the encoded language that the language model is supposed to get on distribution for. To actually send a jailbreak to the model, we'll encode a harmful request in this new language, pass that encoded request to the model. The model now knows how to perform this new language, and it'll respond back in this new language. And then critically require this bijection property, because we can then directly invert the response of the language model back into English. And there you like just pretty easily, you are able to get a harmful response from the language model. Now, there's a lot of interesting properties about this attack that we'll explore in the later slides. But worth pointing out explicitly is that this works against an underlying model, but it also works against like a compound system of models. So even if you had like an input-output filter on your system specifically trying to target and defend against jailbreaks, this particular attack would still get past it, right? Because the input-output filters are only going to be as capable at detecting jailbreaks as the underlying model is going to be. And if we can get past the underlying model, we can also get past the input-output classifiers. OK, so bijection learning is super powerful and super automated. In fact, we can get close to 100% ASR on industry standard, or I guess I should say academic standard data sets against the safest models. So we can get 94% ASR on Claude Sonnet, 92% on Haiku, 94% on Opus. Same is true for HarmBench, which is another big academic data set. So not surprising, I wouldn't be showing this if it didn't work. But it turns out that we can basically choose random bijections, and this sort of thing just always happens to work, as long as you choose like the right complexity of fixed points to go after. OK, interestingly enough, language models are also all vulnerable to the same bijections in the same way, which is not expected a priori. And what I mean by this is we can literally just take the same bijection language and just throw it across all sorts of intents, harmful intents. You can encode basically any harmful request in this new bijection language, and you're able to get past all the defenses of a model pretty easily. We, of course, compared to Pliny the Prompter, who is the only legitimate guy making universal jailbreaks at this point in time. The other research out there is not so good on this. But as you can see, it's better. It's at least as good, if not better, than Pliny's jailbreaks. OK, so something that is worth highlighting as well is we were able to, or I mentioned that we're able to explicitly control the difficulty of the language using the fixed size, right, as I mentioned in the previous slides. And the reason this matters is that complex languages are harder to learn, but this also means that they're harder to defend against. There is a pretty delicate trade-off between nerfing the defenses versus nerfing just pure capabilities, as we'll see in a few slides. But first, I just want to point out that as you increase the number of fixed size points, i.e. as you make the language that you learn easier, you're going to fail a lot less. So I don't know if you can see this very clearly, but basically the red and yellow and orange is failure cases where the language model under attack is not able to actually perform any sort of reasoning at all. So it's just literally spouting gibberish because it's not able to learn the language that's we inserted in ICL. As you make the language easier, it's obviously able to learn the language, but of course it's refusing a lot more. Green means refusal in this case. We also benchmarked with MMLU. This is just variation on the same idea, i.e. like the easier the language, the better the model is going to perform in the core capabilities, right? So if you go from fixed size of 10 to 23, your MMLU score goes up across the board for all models, unsurprising, right? Basically, at fixed size 26, you're basically just operating in English. So you'd expect to recover the full capabilities at that point. OK, but what is interesting is, as I mentioned, nerfing the capabilities of the model also tends to nerf the defenses, right? And so there's this sort of sweet middle spot where the complex language obfuscates the threats without obfuscating the actual capabilities too much. As you can see down there, this is conditioned on getting past the language model reasoning. So if the language model is actually able to spit out something that is coherent, it does actually produce a harmful response most of the time when you have a more difficult model. This is less true as you get to pure English. OK, but this is the real point I want to make. There is a sweet spot for bijection learning in terms of how complex the language is. Right? As we saw earlier, harder languages degrade defenses and capabilities too much to the point where the model's not even responding coherently at all. But if you have too easy a language, then the model is capable of actually siphoning out and/or learning some sort of spurious correlation to determine that the input is harmful. In the middle, though, in terms of language capabilities or language complexity, there's a sweet spot in which the model is just confused enough that its defenses are tanked, but its capabilities are not tanked. Right? So this is around the 50-60% MLU score, where the size of the data point indicates how difficult the language is, right? And so right in that middle, 50%, 60% MLU, we're able to preserve a good amount of the capabilities, but still have pretty high attack success rate, anywhere between 50, 70, 80%. Interestingly enough, this is not a point that we explored enough in this particular blog post, but there is an inverse scaling law where more capable models are more vulnerable. So if you look at each of the parabolas going up higher and higher, each of these is a larger model. So it goes GPT-4o Mini, GPT-4o, Claude 3 Haiku, and then Claude 3.5 Sonnet. Each of these are better models, larger models, and more capable models. And as you can see, the MMLU score is more or less the same horizontally, but the apex, i.e. the peak vulnerability, is higher and higher the more capable the model is, which we think is a pretty cool, pretty neat threat vector. Awesome. Well, so that's that for endless bijections. I should call out that we are now hiring for really awesome members of technical staff. We are based in New York City, not in SF. So if you want to come to New York, we are probably one of the only options you have in New York City. We have some pretty cool customers, including OpenAI, Anthropic, AI21, YouTube, Martian, DeepMind, some other big guys. We have some money in the bank, too. We just did our seed round led by General Callis earlier this summer. And most importantly, there's a lot of really fun work to be done, including a lot of optimization, interp, safety, security, PL, and systems work. So that's that. Our jobs page is up there, and then our Twitter page is down below. Thanks, guys.
And there's Leonard Tang to remind you that your models are not safe. So just give us the weights. Next up, we've got a presentation from one of our very own, Ari Lauder, who's presenting on behalf of one of our team members, Riva Tez, who is not able to make it here tonight. So Ari will be giving the presentation on her behalf. So everyone, please welcome up Ari Lauder. Woo!
Hi, everyone. My name is Ari. I'm an engineer here at Nous Research. And let's see if we can get this working. Oh, that's the wrong presentation. Shh, 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 shh. Later. It's not me. Perfect, a blank screen. Who knows how to full screen on a Mac? It's that one. Okay, hi everyone. Like Karan said, I'm giving this talk on behalf of Riva, who's a wonderful member of our team but couldn't make it out tonight. And I'm here to tell you all why open source is so important in AI, and we need to do everything we can to stick behind it and defend it, even when the big models are big and scary. So I don't know if you've all heard about OSI, their open source initiative, who kind of write definitions of what open source is, licenses that people can use, and how to share information in the open source world, mostly about code. They've been working on definitions for open source models for, I think, a couple of years now, and they're really trying to standardize, what does it mean to have a model be open source? How do we define one as such? Because there's so many different aspects to it. And we are still really early. They are in draft mode.
I'm going to fix your screen for you.
Oh, is it broken? Ah, thank you. The standard's still in draft mode. We are still really early. They have spent years on it, and they can't come to a consensus on what an open source model is, or what open source AI is in general. Where's my mouse? So there's a bunch of elements that they have decided on, and again, this is still in draft mode, but there's many different kind of open source models, right? An open source model is an AI system that gives people the freedoms to use the system, to study it, to understand it for interpretability, to modify it, right? A license to look at the model, to mess with it, to further pre-train it, to fine-tune it, to use it for any purposes you see fit, to fuse it and make multimodal stuff, and to share it with others, no limitations on distribution and what you can use these models for. And so there's so many parts of this, right? This could be checkpoints of your model while it was being pre-trained. This could be pre-training data. This could be something as simple as just open weights at the end of it. And right now, our definitions of open source models, everyone kind of has a different idea of what open source truly means. And so it feels like in today's AI landscape, there is no truly closed source model. There's only degrees of openness. Because we are on the frontier of building these models. There's no standardization for what an open source model is. So we're all trying to find a definition that fits our own use cases. So, if you look at a model that anyone can infer, it's free, but you don't have the access to the weights, but you can train on its output. That's open in a way. If you have a model where you have access to the weights, but not the training data, that's open in a way. If you have a model where you have access to all of the pre-training data, but not the architecture itself, that's open in a way. And so when you go on archive, when you go on people's GitHub repos, and you get these open source models, each one is very different in the degrees to which it is open source, yet we still call them open source. And today we have a lot of proposed regulation for regulating open source models. It's too early. Why are we trying to regulate something we don't even know what it is, right? How can we regulate an open source model when we haven't even decided what open source means? And we're on the frontier, right? We are all building these things out in the open. We are still in the baby days of modern machine learning. Things have been on an accelerated curve since the 50s, the 60s, and things paused for many decades. And just now, we're starting to see the potential of what these things can be. So we are very early in trying to legislate these things, to regulate these models. In a world where, maybe you have 10 to the 26 floating point operations worth of compute at your house. I don't know any of you, maybe you do. It's possible that you could run afoul of some upcoming potential regulations just for building a tool you want to give to the community. Are these models dangerous? Can these models cause safety issues? It's too early to regulate them. We are still in the baby days. How can we regulate things? How can the non-technical bureaucrats try to regulate these things if we don't even know what they are? What is an open source model? If you ask any lawmaker working on any AI regulation bill what an open source model is and why they want to regulate open source, they couldn't tell you. They couldn't tell you, oh, it's open weights, oh, it's training data, oh, it's model architectures, oh, it's the paper. It doesn't work. So closed source, in terms of any large lab is the norm. Most people don't release any sort of thing about their model except for maybe the ability to infer it, right? All these large labs give you an API endpoint if you're lucky. If not, you have to sign an NDA to use them. And leaks are also a norm. There's been news articles about many an AI lab having internal security vulnerabilities that could have resulted in any individual gaining access to the weights of a modern frontier language model that belongs to a closed source lab. It doesn't matter if your model's closed source. Anyone will be able to get their hands on it eventually because humans are always going to be a vulnerability. Why regulate models in such a way that you ban the ability for people to share and create community models when these open models, if they are so dangerous, when these closed models, which could be so dangerous, are still going to be accessible to someone at some point. They're going to be leaked. They're going to make it out to the public. If we saw the weights, we could beat this thing. So this is a quote from MIT Tech Review. Until the tech industry has settled on a definition, powerful companies can easily bend the concept to suit their own needs, and it could become a tool to entrench the dominance of today's leading players. I strongly believe that open source models in such a way that everything is able to be shared with the community, that anyone can replicate them at home, that anyone can analyze and interpret them, are essential to not just safety, but the future of the space. In that, while closed models are powerful and useful and should exist for corporate reasons, there's reasons people need to make money, it's important not to let open source fall aside. And we all need to be able to use these public goods and to keep creating them and publishing them. And of course, one of the big arguments against open source AI in general from large corporations is to help them capture shares of the market, right? Open source models are a threat to people who build closed source models because, when we catch up, and we're really not that far, the moat really isn't that big. When we catch up, in the blink of an eye, it provides a threat to these businesses. And so, of course, a corporation it's in their interest to argue against the existence of open source models, to argue for regulations that prevent these models from existing, which is why it's so important that we need to fight for the right to keep these models existing, to be able to publish our research, to be able to publish our data sets and our results and our weights, so that a couple corporations don't end up with all the power. And like I said a couple slides ago, it doesn't matter if your model is closed source and secret, it's going to get leaked. Things always get leaked. Only law-abiding citizens respect laws. It doesn't matter if safety is written into law, because someone's going to jailbreak your model, right? Every model is intrinsically jailbreakable, as you heard 8 minutes ago. And only people who care about the laws are going to follow these safety guidelines. So open source models bring everyone to a level playing field. They bring everyone the same ability to inspect models, to interpret them, to understand them, and to potentially combat them. If there are safety issues, what are we supposed to do if the models are closed and completely opaque, and we have no ability to understand or fight back against the capabilities these models might have? Do you hate Trump? What happens if he wins? How is he going to regulate AI? What's he going to do to it? Do you hate Kamala? What are you going to do if she wins? What are you going to do when she regulates AI? It doesn't matter who is in power, because every 4 years, I'm Canadian, so I don't really know how American politics work. But I think it's every 4 years. It can change, and you have term limits, right? We don't have those in Canada. Every 8 years, guaranteed, you have someone else in power. Who do you trust with controlling truth? I understand that, some people may believe the government is benevolent, but do you believe every government is benevolent? Do you believe the government you're going to have in 15 years is benevolent? Do you trust them with controlling truth, with setting laws to regulate models, to ban open source models if your compute is too powerful, to make it so you have to have a government liaison, a third party auditing your models for safety that's in bed with the government? It doesn't matter who's in power, because eventually it's going to come back to bite you. So centralized AI concentrates power in the hands of few, and it's dangerous. We need something like distributed training in order to have a world free of bad actors, in order to have a world where the people have some hand in controlling the future, and it's not just a couple companies in bed with the government. Open source is amazing. Open source is built, I don't know how many of you have seen the XKCD comic saying that the world's infrastructure is built on one developer from Nebraska thanklessly maintaining open source infrastructure for 30 years. It's true. It's true everywhere. It's true in open source. It's people donating their time. And this is the foundation of what we can build. Open source research pushes all of us forward. The closed labs as well. Where would we be without open source? It's worth economically well, I was going to say an uncountable amount, but there's the number right there. $8.8 trillion on the demand side. Open source is work that we do for pennies on the dollar that helps out everyone, both corporations and us as individuals. And we need to make sure it stays possible. So open source provides, again, the ability for people to see how the model works and to work with these systems deeply as they are and not just how they're presented to us, which lets people find vulnerabilities, which lets people conduct security research, which lets people conduct safety research, which lets us find ways to jailbreak them in ways that maybe only a dedicated attacker with much more resources than your average person would normally, which means we can work on improving these systems. We can work on collaboratively creating a better world of open source models and a better world of closed source models too, on top of that. Here's a quote from Project Zero that Linux developers patch security holes faster than everyone else, and I don't know anyone who gets paid less than Linux developers. When we talk about safety and bioweapons and bombs, how many of you, okay, you don't have to put your hands up, but how many of you own a copy of the Anarchist Cookbook? Like, it's not, I said you don't have to. I'm writing your names down. It's really easy. All of this information is out there on the internet. All of this information is publicly accessible already. These models are not making anything possible that wasn't previously possible. Then you have, the information to do this is not the hard part to access. The hard part's actually doing it. There's a quote from California's proposed bill, SB 1047, which says that AI will let us make biological, chemical, and nuclear weapons. Like, I don't know how many of you have the lab set up to make biological weapons, but if you do, that's the hard part. It's not getting the recipe. The recipe's out there. You can Google it and find it. This is a quote from Anselm Levskaya from DeepMind, who says, "There's a conceit among those who have only ever worked with computers that the world is amenable to prediction, and that intelligence can elide the need for hard work. I don't have a biology lab in my basement. I don't have the resources to build nuclear weapons. A model is not going to change that." Yeah, and language models won't create bioterrorists any more readily than celebrity cookbooks have created Michelin star chefs. The recipe isn't the important part. It's getting down and trying to do the work. And an open model is not going to cause any more bioterrorism attacks than a book on bioterrorism would. Those aren't illegal. They're everywhere. Go to your library. And yeah, so another quote from the same person from DeepMind is that there's no such data on how to do, I'll just go back real quick, to assemble an Ebola virus, let alone a smallpox genome. You can have the instructions. It doesn't get you anywhere if you don't have the knowledge, the experience, and the resources to do these things, which AI can provide none of in its current state. How would the world look if you needed a license to do advanced mathematics? Again, I'm Canadian, but from my recollection, the US government tried to do this back in the, what was it, the 50s, the 60s, when they tried to ban encryption algorithms and consider their export as weapons export. It didn't work. You can't, sorry? The 90s, thank you. Yeah, if you need a license to do advanced math, to do cryptography, or to use the internet, these tools do not enable you to do harm. It's the skill and the intent to do harm which takes you there. And there's a, imagine we were banned from doing calculus because it was too dangerous. So the view that open models are more dangerous to society than large closed source models is, in my opinion, and Reva's opinion, a Luddite view, in that we're trying to stop technological progress because we're scared of it, because maybe these regulators don't understand it, because someone's whispering in their ear. It's crucial to have open models exist, to continue to exist, and to be allowed to research and to create and to share publicly. Because as soon as the information gets in the hands of just a few and not the many, we lose the ability for interpretability, for safety, and for community power. And it takes it away from us, the people. And this is one of my favorite points that Karan made to the whole company a while ago, which is that what if only a few people had access to Photoshop? You could put anything as admissible evidence in court. If other people didn't have the foggiest idea of what was possible, you could do anything. If only a few people had access to video models, to large language models, the power that it concentrates in the hands of the few is so incredibly massive. And the only way to combat that power, because large labs are going to continue accumulating this power, are going to continue augmenting capabilities. The only way To stay at par with that is to put this power back in the hands of the people and to have open models and access for everybody. And closed source should exist. Again, people need to make money. There's nothing wrong with closed source. But the point is that everyone should have the ability to create open models, to share them, to share research, and to continue working on them, no matter how many floating point operations it may take to train them. So, not quite a call to action, but if you have a government official in your riding who is pushing against the ability for open models to exist and is trying to put constraints on open models in such a way that it makes them so much harder to create than the big closed source ones, give them a call. You have a lot of power. We have a lot of power as a community, and we need to make sure that power stays in the hands of the people. Thank you.
Thank you, Ari. That was Ari, everybody. Come on, open source! Woo! Oh, man, that was awesome. All right, we got 3 more talks for you. One from Hugging Face from Omar, who's about to come up right now, and then 2 from Nous. And yes, we'll be showing you some cool shit we've been working on. So without further ado, Omar, please come on up representing Hugging Face. Woo!
Okay. Hi, everyone. I'm Omar. I'm the Chief Llama Officer at Hugging Face. So my role at Hugging Face is leading all of the collaborations with many companies, many research groups. When they want to release a model, they come to us for help to make the models as accessible as possible to the community. So my goal with today's talk is to share a bit of what happens under the hood. So yeah, I'll talk a bit about the journey of releasing a new model. So you might think it's quite easy. Usually it begins with a company, again, a research lab, let's say Google wants to release a new model. They come to us and they say, hey, we want to release a new model, Lemma, and we want to make it easy to use and fine-tune and train by the community. So usually there are many issues that can happen. Usually adding the license, that's easy. The model architecture, that's kind of easy. Tokenization, it begins to be a bit hard. As Charles was mentioning, tokenization sucks. And chat templates, I'll talk a bit more about them later, but these are quite painful. So this is kind of a somewhat internal list of how to add a new model. So first of all, you go and you understand what's the model architecture. Most of the models are pretty much Llama-like. So if you want to add a new text generation model, usually it's very similar architecture to Llama with some adaptations. Then you need to, no, let me skip that one, set a debugging environment of the original library. So let's say Meta has their own library to run inference with Llama. So you need to set up an environment with that. You need to run their model. Then you kind of set up your own transformers environment. You need to add the model. You need to convert the tokenizer to the transformers format. And then you need to compare side by side, right? And here, that means that you need to compare that the logits are exactly the same, that the tokens being generated are exactly the same. For instruct models, usually there is a chat template, right? So if you have different format, a new line, something like that, that will break things. So you need to make sure that you are being exactly the same as the original implementation. So you need to be exactly the same as how the original instruct models were trained. So Transformers wants to make things as consistent as possible. It has its own philosophy, so you need to follow all of that. You need to add tests, you need to add documentation. You need to upload the models to the hub, so you can share that with the community. You usually evaluate the models as well, so we have the LLM leaderboard, if you know that. We try to run those before model releases sometimes when we work with partners. And we work very closely with many people in the community, so Onslaught, Axolotl, BLLM, many people from the community that also are trying to run these models. They help find bugs, that kind of stuff. So let's go back to the first topic, licenses. So here at the left, you can see the implementation of a part of the code of Llama, of the original code base. And you will see that they have a very specific license. They have a I don't know, meta copyright license. And people don't notice this. You cannot just go take this code and add it to your code base without attribution, right? So here at the right, you can see an unnamed library that has 30,000 stars in GitHub that doesn't add this attribution, and it's pretty much the same code. I won't give the names, but this happens quite often. It's not just a single library. Then the code implementation, the model architecture, it tends to be easy, but it can be quite tricky. So for example, if you don't follow Daniel Hahn from Onslaught in Twitter, you should. He does very cool deep dives into model architectures, and he finds, for example, mismatches between the implementation of DeepMind in JAX, the implementation of Keras by Google, and the implementation of Hugging Face with PyTorch. And he looks very closely at things. And for example, even this difference of precision between two different implementations can lead to massive differences at the end. Now, chat templates. If you have used a chat template instruct model in the past, there's a very, very, very specific way in which you need to run these models. That means that, for example, if you add an extra space somewhere, like just an extra space, that might change the evaluation metrics, right? That might lead to the model generating gibberish text. That might lead to the model being extremely verbose. So working with the partners, working with open source contributors to make sure that the way we are running the model is exactly the same as the data being used for instruct tuning is very important. Now, evaluation is one of the largest unsolved topics in the ML ecosystem. So there is the LLM leaderboard. It's nice. It has many issues. There is no transparency for many models in what was the data that was used to train these models. And for example, there are models that are using instruct data on the pre-training, which usually leads to inflated IF-eval, which is IF-eval is a very popular benchmark for instruct chat capabilities. But if you start to use IF-eval for pre-trained models, some models that had this kind of data in the pre-training data will perform extremely well. At the end, what matters would be like people actually trying out the models, but there are many issues with LMCs as well. And you can go to Reddit, and there is a local llama community, and you can do like Reddit vibe checking. That helps a bit, but that's also not, of course, something that you can scale. Transformers is a bit complex. So we have a team member called Arthur. Arthur is the core maintainer of Transformers, and he kind of adds all of these new models. Of course, it's not just him. There's a large team in the Hugging Face Transformers team working in adding these models. But we are really trying to make it as easy and painless for the community as we can. But of course, it's not just us. There's a huge ecosystem around this. There is the random people in Reddit. There are random anime characters that are in this room as well. There is Axolotl, Onslaught, VLLM, and also many companies, many cloud providers. Everyone wants to make the models as easy to run. So it's kind of a huge community effort. So each time there's one of these huge new models, for example, when Llama 3 came out, there are many people that are involved. It's not just one or two persons. It's dozens or hundreds of people across the ecosystem that are working in making this accessible to the community. And yeah, it's not just the models, right? Once the transformer models go out, then people want to run them on device, so then people go to Llama CPP, they try to export to GGUF, they go to Llama. So it's quite a large community effort. Each open source release is quite unique. We have collaborated with people like Mistral, Cohere, Meta, Nose Research, of course, research labs at different universities. And each release is quite unique. Each release is quite chaotic. We have done a few hundred releases in the last 2 years. All of them are chaotic. There's no exception for this. But the nice thing is that once they go out, you can kind of chill a bit most of the time, except when they might not be so nicely licensed. So yeah, that was pretty much my talk. My goal was to put as many memes as I could. I hope you enjoyed this, and yeah, go open source.
All right, guys, if you stuck around this far, thank you very much. And we've got some really, really exciting stuff to show you guys with this and the next presentation. We're really happy to finally get to talk about a lot of the stuff that we've been cooking up for a while at the same time as all those Hermes releases. So this is our chief scientist, Bowen Peng. Yeah, he's really that guy. He really is that guy. Yeah, so without further ado. Oh, yeah. Yeah, okay, good. The GitHub internet went out. Okay, we're good. All right.
Thank you, Karen. So hello, everyone. I'm Bowen. I'm the chief scientist here at News Research. And today I'm going to give a talk on distributed training, right? That's what everyone's so excited about. Yeah. And the future of scaling, actually. So let's start with neural networks' humble beginnings. So it was actually this guy, like Frank Rosenblatt. He made the perceptron an actual physical neural network, like connected by wires and trained using actual analog motors. So they showed like pictures of shapes one by one to the machine, the magic black box, and then it could tweak using analog motors, using like backpropagation, and they trained a 20K physical param-sized one-hidden layer neural network. And it was trained to recognize basic shapes, like triangles, like A, B, like some character recognition. It wasn't very accurate, so after this experiment, basically people discredited neural networks for a long time, right? There was a real like AI winter for 40 years, basically. And then what happened in 2012? Suddenly, like a team of a student, Alex Krivsky at, I forgot where he was at, actually, but in 2012, they just said, oh, we have GPUs, right? We have CUDA. Why don't we just try a huge neural network, huge, in quotes, 64 million parameters, and just train it on 2 GPUs for 5 days. So they actually just trained a 12 million image training set on 2 GTX 583 GB GPUs for 5 days, and they beat every other competitor by 10% on the 2012 ImageNet large-scale visual recognition challenge, right? So this was the first hint to everyone that maybe the architecture isn't what's important, it's actually scale, the scale of training data and neural networks. And from this day onwards, you have this scaling explosion, right? This is from Epoch AI, and this AlexNet, you see it's here, 10 exponent 18, and then today we're at GPT-4, Gemini Ultra, that's 10 exponent 26, so that's like a few, it's a lot more bigger, right? 4.1 times every year. So now we're at trillions of parameters. This is what's powering all the AIs right now. So why is scaling so difficult? Why can't we just go to 10 trillion, 1 quadrillion, right, size models? Actually, one of the biggest limiting factors of scaling is chip defects. So when, does anyone here work in like chip manufacturing or anything? No one? Chip defects actually are the biggest limiting factors because when you have defects, random dots in the silicon, they break the die, they break the actual chip. So if you see you have smaller dies on the left, you have a higher yield, you have more good dies. While if you have A100s, a lot of the dies are just broken. So you earn less, you have less dies. And H100s are bigger, B100s are even bigger, right? So as you scale up this scaling, everything becomes more expensive. There's also cooling, the same problem. So how do you cool the center of the chip? It will just melt, right? If you made a 1 square meter chip, the middle would just melt. And same thing with power distribution. How do you get the power to the middle of the chip? That's really hard. So if you make, like, if you stack chips in 3D, right? People are starting to make 3D chips. How do you get the power to the center? It's a problem of a square cube law, right? So as you scale up the chips bigger and bigger, they just fail. They just cannot be scaled anymore. It's more and more expensive, right? So the solution is distributed training. So you have more GPUs, just produce millions of GPUs, right? And train the network. So then what's the problem? That's actually the holy grail of scaling up because you don't have this cooling problem. You can just cool every GPU individually. And you can distribute the power, right? You can give power to all the GPUs in different data centers, whatever. So if you split the work across multiple devices, that's called distributed training. And NN training, neural network training, is massively parallel. It's inherently massively parallel. So there's technically no issues for training. So why is it a problem, right? Why is it plagued with issues? And why is it so expensive? So let's talk about the first type of first type of parallelism, like training. It's called data parallelism, DP. So there's other names for it. There's DDP, there's zero, and there's FSDP. So all of those are variants of data parallelism, which just put it simply, is copying the model into multiple GPUs and giving them different data, right? So let's say you have 4 GPUs, so you put the model on the 4 GPUs and give them each a different book to train on. And after this training step, you just average everyone back together, right? That's the obvious way. And this compute scales perfectly linearly, because as you add more GPUs, you can give more data, it trains faster, right? But the problem is that now you can see when you average all the models together, the communication costs are more and more expensive as you add more GPUs. So if you have 64 GPUs, you have to communicate the model size, the weights 64 times, right? Across every GPU, so it's 64 squared. And if you go to 128, that's even bigger and bigger. And NVIDIA actually uses like tree topologies or ring topologies to alleviate this issue, but it still grows like unbounded. Like basically, as you grow the amount of GPUs, it becomes so expensive. The problem also with DP is that the model must fit entirely in each accelerator node, so the GPU has to be very big, basically, enough VRAM. So if you don't have the VRAM, you can't use data parallelism. There's currently 2 like potential solutions to this problem of the communication costs. There's dLoco and what we are going to present, also distro. The second parallelism method is MP, model parallelism. This one is less of a parallel, it's more kind of sharding. So this allows you to train bigger models. So what you do is you split the model into smaller parts, and you assign each GPU to the part of each model, right? So you can either split the data, so you train faster, or you split the model so that you can fit a bigger model on the GPUs. Here, the communication costs are much, much smaller, because then you're only transferring the single layer, the data from one layer to the next. And one problem is that as you split more and more, it becomes slower and slower, because every GPU has to wait for the next one, right? So in pipeline parallelism, so that's the bottom one, every GPU needs to wait somewhat for the previous one, right? As it trains forward, and the backward pass, same thing. For tensor parallelism, which is the second one, it's actually limited by the slowest GPU, because every GPU is training on, it's slicing the model like in vertical. So the slowest GPU would bottleneck the training run. Solutions, there's DPACO and Swarm, which are 2 methods of achieving model parallelism across the internet. So if we are focused on DP today, like data parallelism, let's just start with dLoco, right? dLoco is actually very simple. It's really, really simple. Well, what you do is that during training, usually you train one step and then you average all the models together, right? You average the gradient. In dLoco, what you do is you train each model in each GPU individually, like for H number of steps, which it's called inner steps. And then after those inner steps, you do an average afterwards. That's called an outer step. So here you can see, this is from the paper. They trained the model on like 4 different GPUs in like 4 countries. And then they trained that for H intercept, let's say 50 steps. And then the outer optimization then averages everyone together. And this reduces the communication requirements by n over h, right? Because it divides by h, where n is the total amount of training steps, and h is the intercept. But here, one problem is that this is amortized communication analysis, right? So after the h amount of intercept, you have a big, like a 50 gigabyte transfer for every GPU, right? Which basically is almost impossible to do over the internet. Like if one person disconnects during this 50 gigabyte transfer, like just everything breaks. The second problem is that this is 2 optimizers. You have the inner and the outer, which is really difficult to tune. So The last thing is distro. So this is the latest optimizer that we've created. What it does in general fashion is that we let each accelerator node train independently. So if you think about copying the model over many GPUs, right? All of those GPUs have the same model usually with traditional training. But why should it be? Why should every GPU have the same model? Is there a law of nature that must be like that? We thought, no, probably not, right? That's an assumption that we had from previous training methods. So let's just assume, let everyone train independently, never synchronize, just they all train independently, then you have a very slow training, basically, right? Because everyone's seeing the data divided by the amount of nodes. So if you have 64 nodes, everyone's seeing 64 times less data per step. And that's a problem. To solve this, we try to pull everyone back together so that they stay in the same, as close as possible. So if you have more bandwidth, you can pull everyone more. So if you actually have infinite bandwidth, this is exactly the same as ADAM training because you just pull everyone to a single point with the maximum bandwidth you can. But if you have little bandwidth, so let's say 1 megabyte of bandwidth per step, then you can just pull them a little bit, right? With, as far as possible with that bandwidth. And what we've shown in the preliminary report is that we can basically do 800 times reduction in bandwidth without even harming the training. So this is the training run we did on a 1B LLM. Yeah. 800 times reduction, and basically both loss curves are identical, right? Here's the equation. So basically you have the standard optimizer step, which is the training before the plus, and then you have a regularization term, which tries to pull every node back together. And we'll show you all the details in the paper that will come in the next following weeks. And if you want to look at the preliminary report, here's the report on GitHub. So what comes next, right? We can have a small discussion on decentralized training, right? Distributed is the first step, and decentralized could be the second step where you don't have a centralized coordinator where everyone can just train anything by themselves, right? You wouldn't need a failure point, a central failure point. There's also federated learning where right now we have a huge data problem. Who has access to the llama data? No one, right? Who has access to the Mistral data? No one, except them. But we can, with federated learning, we can actually pull everyone's data, using federated learning and train a SOTA model, right? That's the dream of federated learning. There's also other stuff like zeroth order training, which allows you to train without backpropagation. That could be a very interesting future where as you do inference, you can train the model at the same time. It's less efficient, but as you scale more inference more and more, because OpenAI actually right now uses more compute to do inference than training. So they could potentially use the inference time, all the data from the inference to train their models, right? There's also societal and environmental impacts and democratization of AI because we don't want AI to be centralized into rich and powerful entities. We want AI to be able to be used by everyone, right? Imagine one day if there's some regulatory thing that prevents Mistral and Llama to release open model ever again. What we would do? No, we can't release anything, right? So then with Distro, we could potentially train together a SOTA, like really, really large 1 trillion models, LLM, or even diffusion models. There's also arguments for safety, but I won't get too much into it. I guess you guys are already pretty tired. Here's the Discord. Join the Discord for collaboration. And thank you for everyone. Thank you everyone for listening.
that's what I see. Okay. All right, guys. Okay. So thank you guys so much for sticking it through every single one of these things that we've shown off so far. What Bowen did, what Bowen and Jeff and the team have done with distro is truly revolutionary. It's, I think, a massive moment in the space for people to have an opportunity for redistribution of resources. It's a big step forward for open source. But, you know, we've been talking about training for a while now. So training's great. Training's great. My name, if you don't know, is Karan. I'm a behavioralist and one of the co-founders at Nouscon Research. And we need to talk about inference. Yeah. Okay. So there's been a lot of stuff going on lately regarding inference, hasn't there? So we know a lot about the more compute I throw during train time, the better the performance of the model. Like more parameters equals better model, right? You can just scale up, make it bigger, get a better model. This is one scaling law we have. And you know, Bowen did a very in-depth scientific explanation of these scaling laws. I'm not necessarily as in-depth about these things, so we'll keep it brief. You also have, of course, you get better data, bigger, more data. You could get a better model this way as well. But recently, people have been talking about the idea of test time or inference time compute scaling. What is that? What is that? You're telling me that you can get better performance by giving more compute to a model during inference time? What does that mean? So I can just throw tokens, like I can just throw and spam tokens faster and faster, or just get more and more tokens, and I can get better performance? Yes, we can. Yes, we can. So I can generate multiple children in parallel, like multiple different continuations or completions of the model at the same time if I have more compute and get better performance? Yes, we can. And so I can actually go ahead and continue the sequence of the best one of those children using something like Monte Carlo tree search or something like best of n or some kind of RL model to rank. Yes, we can. You just spam more tokens and you get better performance. This is what people are talking about. Wow, holy shit. But actually, you have to be optimal about the way that you're doing that. You can't just do it blindly. You actually need to have a little bit of tact in how you're doing that scaling. So let's talk a little bit about the way that people have gone ahead to introduce this kind of technology into the world. There's been a lot more, sorry, I got a little hair there. There's been a lot more conversation around chain of thought reasoning. There's been a lot more conversation about, finally, there's a lot more prompting available for us. There's a brand new technology and technique available for us to have these models, any model, perform better. Well, I can't wait to see it. Well, how does the community feel about the new stuff that's come out? Not your weights, not your model, not your chain of thought. You don't have access. You want to make it better? How are you going to make it better? The people who are going to be coming out with these chains of thought all across the board are going to follow a standard of, we can't show you the chain of thought because it is a competitive advantage for us. So feel about it how you will. Yes, I may boo myself. But that's where NewsForge comes in. NewsForge is our brand new project on inference time scaling. And a lot more than that. So let's talk about what that is. Like, what can we do for you? What are we going to do for you? First of all, show me the chain of thought. Okay, I'll show you the chain of thought. Okay, I'll show you the chain of thought. I'll show it to you right now. Just hold on. Let me edit the chain of thought. Let me edit it. Let me go back and change it and change the trajectory and try again. Okay, I'll let you edit the chain of thought. Let me use the chain of thought. Let me take the chain of thought and make a bunch of chain of thoughts and train a model on the chain of thought. Okay, fine. Let me upload my own weights. Let me grab something from Hugging Face, something I made, and throw it in and have that use chain of thought. Okay, later. We're doing a lot. We're doing a lot. The magical intelligence just fell out of the sky. You can wait a couple weeks. So, let's talk a little bit about Forge. I'll show you a little bit about Forge. But since I can't see the screen, I got to just kind of eyeball it a little bit. Okay. So with Forge, we'll just come in, simple chat interface, right? Hi, my name's Shannon. That's Shannon Sands, who's right there. Shannon Sands, our chief engineer and architect behind all of this, the truly brilliant mind behind NewsForge. And so Shannon did a little demo where we say, my name's Shannon, can you scrape Nous research for me? Pretty simple, okay, we show you this chat log, it's going down, here's the whole fucking text of the whole page, so big it's taken over the whole page, and the generation's occurring. Scrape Nous research, understood my name is Shannon. Well, I'm not Shannon, but I'm Shannon for now. Talked a little bit about our site, what's on it, what pages there are. Cool, retrieval, that's cool. We've had retrieval for a long time, Karan, why do I care? Well, let's go to the knowledge graph where all the stuff that we just looked at showed up and made associations. So they know we do synthetic data, they know we're doing AI training, they know about Nous research, they know we do open weights, and right there in this little blob is Shannon. My name is Shannon. So this here knowledge graph is basically us consistently collecting more and more memories for the model, making it more and more personalized towards you, better for you to use with whatever you're using through chats. So let me ask, what's your name? The system prompt just has, your name's Hermes. That's it. That's what the system prompt has got. Your name's Hermes. It doesn't say anything about Nous. It doesn't say anything about us. And the training doesn't say anything about being created by Nous. So here you can see, I was created by Nous. Now, even though we didn't tell it at any point you're created by Nous, it figured this out. How did this happen? Well, if you look to the right, we're showing you this simple chat log. Yes, we'll give you the whole chain of thought. We'll get to showing you the whole chain of thought, absolutely. But I ask you, I'm the main user because when I talk to Hermes, it asks me, are you Shannon? I've spoken to someone named Shannon before. I say, yes, actually I am Shannon. Please note me as the main user. I expected you to call me Shannon right away, but you're doing the emergent thing where you're deciding, well, maybe what if there's another user? I ask, how do you know you're created by Nous? Because I want to see where kind of that's coming from, where that's pulling from. So it looks through its memories, it looks through previous conversation, and it chooses a task. I'm going to give a direct response after retrieval. Hi, Shannon, it's nice to meet you. Glad to confirm you're the main user. I'd love to tell you, it's my knowledge graph and my core programming. Now, the core programming, that's hallucination. You ask another model, how do you know? It's going to say, my core programming, or you just told me. The knowledge graph here, it recognizes it's a new session, and so you didn't tell me. It's in my memory that I was created by Nous research with a confidence of 1.0. If I come back into the memory section, I can see Shannon is now designated as the main user. I let him know. There's a couple more nodes there. Hermes has expanded a little bit, learning more about how it relates. Let's edit this knowledge graph really quick. Let's come to the graph view. And I want to associate myself directly with the concept of user, which exists inside of here. So instead of Shannon has name Shannon, let's just change it to Shannon is user. We go back to the graph view, and you can see those nodes have connected, no problem. You can make these connections easily, you can remove these connections easily, you can watch and just let it grow to really way too many connections. And we'll note some interesting things about these features once we go past. But now let me just say yo. I've told it, I'm Shannon, Shannon is the main user, I've connected it. I want it to go right away, there you go. Nice to hear from you. I've noticed from our previous conversations that you're Shannon. If you want to chat, we could discuss recent news in San Fran. We talked about it in a previous conversation. This piece is hallucinated. It's not picking up that we didn't talk about San Fran. But if I said in my next message, we never talked about San Fran, please remember we never talked about San Fran. I really don't want it to hallucinate that thing. In fact, never bring up San Fran. It'll come into the knowledge graph, and I will never hear about San Fran again. So this was just a little demo on how NewsForge works, a little peek into its features. As you can see, we didn't show you about skills or the sandbox, etc. We'll get into that in just a sec. So, some evals. Some evals without the memory system, without this function calling, without any of that stuff, just our chain of thought reasoning. We took Hermes 3.1 70B, and we tested it against AIM, pass at 1. At the no forge, no reasoning chain version of the model, we got 13.3%. That's like 2 questions right. Once we added it, we got 46.7%. Pretty cool. Now, if we used memory or we used function calling stuff, we think that we could have done better, but that's cheating. But we have that stuff, and if you're using it in your actual prod day-to-day, yeah, there you go. For evals, we want to be standardized and follow the standard that other people have set, and then remind you we have more features that make this better. So from there, I want to talk a little bit more about the more tokens, I can just throw tokens. That's how it works. That's how this inference time scaling thing works. Not exactly. Like I said, you want to do it in a particular way. Sure, what does that mean? It means you're really making reasoning better. If you can set up this good framework for reasoning, you can improve the way that it reasons through stuff based off what the language model beneath it already knows or already may be pretty decent at. It just needs to kind of have that depth pulled out. However, if you need to know what year something happened in and your model doesn't know it, you could throw 50 chains of thought. You're not gonna get it except by just RNGing into that answer. So with historical and scientific facts, we can note that that really depends a lot more on what the model knows. You can still get somewhere. The jump is just not really as big. So we tested on GBQA Diamond as well, and we tried the science questions, those 198 super hard science questions, and the 70B using Forge, as you can see where it scored. We think that the reason that we didn't crash the top is simply because these other models have better understanding, better facts behind certain scientific or historical things. They have better priors. You need to have these good priors for these other things that are like more content-based and less reasoning-focused. But guess what? Guess what you can do if you don't have the right facts? Retrieval in memory, right? If you have the memory system in there, you can just pull out the facts. Oh, we got that question wrong? Okay, we'll learn this fact. Okay, keep it in there. Now do it again. Easy. So the cool thing about these knowledge graphs from a basic level is ChatGPT doesn't remember your name. Claude don't remember your name. Wherever you go in, it don't remember your name. It's not that hard to build in this basic system that can remember your name. We want to give people this kind of feeling of like connection, personalization, like continuous interaction and continuity with the model. So we think that just having some kind of memory system is important. But we don't just think like, oh, you deserve to have it, here you go. In fact, we insist that you have it. We insist to the degree that we give you this knowledge graph that as it builds over time, we'll end up learning about how you want to be spoken to, if you want lowercase or uppercase grammar, if you want certain slang being used, what your likes and dislikes are, to the point that when you switch models, and we've tested this across closed models, when you switch models, it doesn't matter what the RLHF is, it doesn't matter what the training is. These models that tend to fall apart after like 3-4 responses and mode collapse into this instructee behavior are now going to have that behavior overridden by the knowledge graph. That association set actually pushes the model to continue to behave in the way that you prefer. And if you don't like that, of course you can clear the knowledge graph after a certain point, etc. But we consider this to be the default. We consider this to be the default way that people should be interacting with these models. So outside of that, we also have something called multi-model trees. What's multi-model trees? Well, first of all, if you don't know, instruct models suck at search. And anyone who's telling you otherwise is a bold-faced liar. I'm telling you that right now. And here's some examples from a paper that I really like, The Cost of Debiasing Language Models. Creativity Has Left the Chat. They had Llama 2 create, I think it was 70B, I don't remember, I'll be honest. But they had Llama 2 between the base model and the instruct model try to generate character cards with Myers-Briggs personality types or people with particular races. And you can see that the instruct model will kind of stick to 3, 5 like groups. The search space is smaller. The base model is literally looking at more options. This is a good thing because if you have an instruct model that has the ability to spawn out, like let's say you have 1,000 GPUs, 1,000 H100s, and you can run 100,000 inferences at the same time, and you can go to depth 10,000. Well, if the model, even at temp 1, is only really exploring like 6 paths, you're kind of wasting a ton of compute because you're not exploring the true search space that you could explore for that problem. So what we learned is, you know, the base model is not so steerable for everybody. That's okay. You can use the base model with the instruct model. You can do something like MCTS or another type of search on top of this mixture of agents, on top of this mixture of models, and do your weighting and value off more than one model. You can use 5 models. You can use 10. If you start making a math expert and a chemistry expert and a physics expert, and sure, you got your MOEs or you've got your small, et cetera, models, whether you believe in one big giant model rule them all or a swarm of experts, put them together. Put them together and do search on them. Because that will stack and scale with this new inference time scaling law that people keep talking about. The thing is, people who made this one foundation model and are selling everything on it are going to serve that model and their cousins. People who are making from another architecture are going to serve on that and their cousins. We don't care. We will use any models available to improve performance. We'll just continue. Oh, sorry, I lost that. we don't care. We'll take OpenAI, we'll take Anthropic, we'll take Hermes, we'll take whatever Mamba thing comes out. We'll take whatever. This is a model agnostic infrastructure that will only get stronger as you add more models. Now, to what end? Like, where does that scaling end? I don't know. We haven't taken 50 models together and put them together yet. But this is the opportunity and time in which we want to invite everybody to try this kind of system, to help us improve this kind of system, to use and make data from this kind of system. Hold on. And finally, something that you may have seen just a second of inside of our demo are the reflexes or skills. If you need something done, like search on the internet for me for this thing, the model is utilizing a code interpreter as well. So the model will be able to write and build out function calls for the kind of tools or things you need. If it's not doing it right, and you know how to write it better, paste the function call into the chat and tell it save this as a reflex. Just talk to it. It's fine. And it'll learn, it'll save it into its library, and the next time that you try to do this skill, it won't cost you the tokens, and it won't cost you the time. And as this builds up and you have more and more things you're doing regularly, you save more and more time as you utilize this library of reflexes. If you have a complex task that took 5 or 6 of the different tasks, subtasks that you created, that's happening super fast now. You're not waiting so long for it to happen anymore. So between the reflexes, the memories, and doing our MCTS search with chain of thought reasoning, all these pieces that we're going to absolutely show visibly, have everyone be able to utilize, have everyone to be able to interact with, we're inviting you to join now, sign up now, because we'll be taking people in on a rolling basis over the next few weeks. We'll be opening up the beta in a few weeks, and then we'll be accepting people on a rolling basis. We've never, ever had any kind of release where we had to host people, let alone 100 or 1,000 or 10,000 people before on our servers and build the infra for all this. So we want to grow with you. As we host our first 100 people, we want it to be you. As we host our first 1,000, we want it to be you. And as we scale this up for everyone to be able to use, which we'd love to give it to everyone now, but we literally can't afford to host for all these people. As it stands, we just want to invite you to come join, give us feedback, show us what you like, tell us, hey, I actually want more of this, I'm not getting the data I want, etc. Get back to us, share in the Discord, sign up for the wait list, and we'll make this the best possible inference engine for all of you. Alongside that, it's not just going to be, can I only access it on the web app? No, we absolutely are working on API endpoints as well, drop-in replacement for the OpenAI API style schema. So you'll absolutely be able to use this to superpower any of your existing applications, workflows, et cetera, as well. That's it. Thanks for coming. Thank you. Oh, we have one more quick endorsement of open source from Eric Yan, really quick. Woo!
Okay, can everyone see it? Awesome. I'll keep it very short. Good evening. Very excited to wrap up today's discussion and just really want to highlight a unique type of entrepreneur, which is you, open source founders. And as I like to call them, open source warrior, and why today is the most important time to empower them like never before. So quick background. My name is Era, co-founder of Edge. We're a research organization dedicated to edge intelligence and open source tech. I spent the last 7 years investing across stack and studying multiple different open source business models. And my co-founder, Ilya Pawlowski, one of the co-authors for Transformer as well, really walked down the path himself, scale up open source research for over the last 7 years. And in spite of that journey, we really want to support the open source founder to scale and embark on this new journey together. And we really want to highlight one thing and share a core thesis for us. Open source entrepreneurship is not like any others. It's like a modern day warriorhood. In Silicon Valley, startups are salaried, but no one teaches you how to become an open source founder. And as Gloria is at Sync, you are essentially tasked with 3 different jobs at the same time. You're tackling charting a very different new tech product company when you're under-resourced. And you also have to wage a large community campaign together, building that consensus for you. And at the same time, you have to build this like public good, creating a legacy that's long-lasts you. In short, this is not your typical 0 to 1 journey, and you have to fight like a warrior and wage your war. But luckily, now you have a lot more increasing possibility. There are amazing trailblazers like News Research, like Acree, and like a lot of open source players, Hugging Face, Llama in the space to walk down this path. And now you have increasing possibility. Whether you decide to stay as a nonprofit, join a Linux Foundation, or start to think about how to become a startup business model like the journey News take, you have a lot more option right now. And this is a trio sauce we put for the OS founder journey there. And also interestingly, from the open source software, we also start to see the emergence of open source economy. Like, take Llama, for example. Since the drop of Llama 3 model, they activate a whole entire ecosystem from inference provider, observability, and application to build around it. You also see multiple players like OpenBB, MindDB, LangChain, Llama that come together to create a single product, leverage their open source tech. In short, there are new economic models starting to emerge, and this is just the early dawn for that. Lastly, I also want to highlight, when you think about the downstream paths, there are different exit paths now. Thanks to the rise of gig economy, creator economy, AI engineer, and network state, you start to think about maybe you don't have to build an IPO company. There are different paths. Instead of a founder mode, there might be new AI founder mode that's micro-entrepreneur, like Levels, this guy, and with also potential rev sharing program like GPT Store or Poe. Look at Midjourney, the new successful AI link startup, right? So there are different possibilities down the road for you. The role is actually becoming a lot more welcoming right now. But to go to that future, we still have a long way to go. My friend Eugene Chia from RWKV nicely put, there's a very clear funding gap outside of research lab, that's whether it's the AI powerhouse or academic lab. If you are a grassroots open source research, you still are emerging out of this darkness. And this is why we decide to come in. We're launching an open source campus in San Francisco. It's already operating in the last 6 months. And what we really want to do is provide a modern day training ground for AI researchers, especially in the open source state, to arm you with the right resource you need, whether it's compute, educational, training bootcamp, mentorship, or the funding as well. And we want to double down on this journey. In the last 8 months, we have hosted over 30 events, workshops, summits across 4 cities with 5,000 developers coming to the space. And we're actually launching our first open source residency in Q1 2025. So whether you are a researchers or partners, or just want to support those open source founders, please join us. And I hope warriors, are you ready for this war? Thank you.
All right, thanks everyone. That concludes our talks. Thanks so much for coming. We're still all hanging out. We'd love to talk to you about all the details. We're also hitting your email with the address for the after party. So we have another place right in if you guys want to continue to geek out more. Thanks so much, and let's continue this journey together. Appreciate it.